In this tutorial, you'll learn how to predict where a small molecule ligand docks onto a protein. In particular, we will be using the DiffDock method. To run this docking prediction, you will need a small molecule in a small string format and a protein structure in a PDB format. For the small molecule, let's use Copilot's built-in PubChem search function to find the small string for uric acid. This finds the string and generates a structure to show in the visualizer on the right. For the protein structure, let's upload a PDB file using the paperclip icon. Uploads are automatically named, and here it's called U1. Now that we have all the inputs, we can ask Copilot to dock S1 into U1. For this particular score, the higher the better. Let's try a different protein for comparison. This time, let's use the built-in search to look for a uricase protein from the UniProt database. We can then get the structure prediction by asking Copilot to fold the UniProt ID P04670. Remember that we have to do this because DiffDock requires a PDB as part of the input. Now that we have a structure, we can predict the docking of S1 on P1, which uses the DiffDock method as before. And now we can easily evaluate the results by asking Copilot to compare S1 plus U1 and S1 plus P1. This compare table shows a number of useful metrics. For example, PLDTT is a measure of the structure prediction confidence. It ranges from 0 to 100, and generally 80 or above is considered good. Not all PDBs necessarily have an associated PLDTT, which is why the uploaded protein U1 is not showing this column. P-ident, or percent identity, is a measure of sequence similarity. It ranges from 0 for no match to 1.0 for 100% sequence match. In these tables, the first column is the reference for comparative metrics, so P-ident for column 1 is 1.0. What P-ident score is considered good versus bad will depend on your application. AA-comp, or amino acid composition, is a measure of how similar the distribution of amino acids in a sequence is from quote-unquote natural sequences. This ranges from 0 to 1.0, where 0 means completely different from natural sequences, and 1.0 means exact match. Most natural sequences have an AA-comp value of 0.8 or higher. Length is simply the number of amino acids in the protein sequence. TM score is a measure of structural similarity. It ranges from 0 to 1.0, where 0 means that there is no structural overlap, and 1.0 means perfect 3D alignment. A score of 0.5 or higher is a generally used cutoff for quote-unquote similar folds. The DiffDock score is specific to the DiffDock method. It can be a negative or a positive number, where a higher number is considered better. Finally, ProtNLM is a sequence-to-function prediction model. Given a protein sequence, it provides a rank-ordered list of predicted functional annotations. Thank you for watching, and see you in the next one.